Infix, postfix, and prefix expressions. What is an infix expression? It's the kind of expression that we're all used to. It's where the operators are placed in between the numbers. A postfix expression is where the operator is placed after the numbers, hence the word post in the name postfix. And a prefix expression is where the operator is placed before the numbers. Now, why would we ever want to use a postfix expression? Well, the reason for that is while we as humans may feel more comfortable reading an infix expression, it's very hard to write a calculator program that's able to read infix expressions as input. It's much easier to implement them reading postfix expressions. And we'll go into more detail on that later. But the focus of this video is on how do we convert an infix expression to a postfix expression. And to do that, we have to review a concept taught back in early grade school called PEMDAS. For those who may not remember, PEMDAS is an acronym where the P stands for parentheses, E for exponent, M for multiply, D for divide, A for add, S for subtract. And the purpose of PEMDAS is just to remind us the rules of precedence when doing arithmetic expressions. All right, recall that parentheses always have the greatest precedence. Exponents have second highest precedence. Multiplication and division are tied for third, and addition and subtraction are tied for fourth. Alright, so here's the first expression that we're going to convert. 20 plus 8 minus 3 plus 10. The first thing we're going to do is to take each operator at each number and make it an individual token and insert these tokens into a queue of tokens in the order that they appear in the expression. And then the output of this algorithm will be a queue of tokens as well, where the tokens will appear in the order that they should appear in the postfix expression. And over the course of this algorithm, we're going to use a stack called opstack to aid us in this algorithm. I call it opstack because that is short for operator stack. The operators will be going in and out of this stack over the course of the algorithm. So, here's how it goes. First step, 20 is a number. Whenever we encounter a number, move it straight to the output. Plus is an operator, we push it to the op stack. 8 is a number, move it to the output. Minus is an operator, we want to push it on the op stack, but first we need to compare its precedence to the current top operator, which is plus. Since minus has equal precedence, we're going to pop the stack first, then push minus. Whenever the operator has less than or equal precedence to the current top operator, we pop the stack first, then push it. Next, 3 is a number, move it straight to the output. Plus is an operator. Before we push it, we compare it to minus. Plus and minus have equal precedence, so we pop minus first, then push plus. 10 is a number, move it to the output. The input is empty, so we simply empty the op stack to give us our final expression. Next, we got 50 plus 20 times 2 divided by 4. 50 is a number, straight to the output. Plus is an operator, straight to the operator stack. 20 is a number, straight to the output. Multiplication is an operator with greater precedence than plus, so we push it on top. 2 is a number, straight to the output. Division is an operator with equal precedence to multiplication, so we pop multiplication, but it has greater precedence than plus, so we push it on top of plus. 4 is a number, straight to the output. The input is empty, thus we empty the stack onto the output to give us our final answer. Next, we got 50 times 5 squared minus 15. 50 is a number, straight to the output. Multiplication is an operator, straight to the stack. 5 is a number, straight to the output. Exponent is an operator with greater precedence than multiplication, thus we move it to the op stack. 2 is a number, straight to the output. Minus is an operator with less precedence than the exponent operator, so we pop it. It also has less precedence than multiplication, so we pop that as well. Then push minus onto the stack. 15 is a number, straight to the output. The input is now empty, thus we empty the stack onto the output, giving us our final answer. Next, we got 20 times 5 plus 3 wrapped in a pair of parentheses divided by 4. 20 is a number, straight to the output. Multiplication is an operator, straight to the stack. Next, we got open parentheses. Parentheses has the greatest precedence of all, thus it goes straight on top. 5 is a number, straight to the output. Plus is an operator with less precedence than open parentheses. However, we treat parentheses different from the other binary operators. Open parentheses will not get popped until the corresponding closed parentheses gets met. Thus, plus will get pushed on top of it. Next, 3 is a number, so it goes straight to the output. Now we've met the corresponding closed parentheses, so what we're going to do now is pop the stack until we reach that corresponding open parentheses. Once we do that, we get rid of the parentheses tokens because we no longer need them. Next, we got division. Division and multiplication, equal precedence, so we pop the stack, then push division onto it. 4 is a number, straight to the output. Input is empty, thus we pop the stack onto the output to get our final expression. Next, we got 10 times 4 plus 3 times 2 wrapped in a pair of parentheses minus 5. Thus, now onto our input. 10 is a number, straight to the output. Multiplication is an operator, straight to the stack. Open parentheses, greatest precedence of all, push on top of the stack. 4 is a number, straight to the output. Plus is an operator with less precedence. However, we're not going to pop that open parentheses until we meet the corresponding closed parentheses. So plus will go on top. 3 is a number, straight to the output. Multiplication, larger precedence than plus, so we push it on top. 2 is a number, straight to the output. Now we've met the corresponding close parentheses, so we're going to pop the stack until we reach the corresponding open parentheses. Then we're going to discard the tokens. We no longer need them. Next, we got minus. Minus has less precedence than multiplication, so we're going to pop the stack, then push minus onto it. 5 is a number, straight to the output. The input is empty, thus we pop the stack to get our final expression. So, in summary, as you process each individual token in the input, if the token is a number, simply enqueue the token onto the output. If the token is a binary operator and the stack is empty, then push the operator onto the stack. If the operator has greater precedence than the op stack's current top operator, then push the operator onto the op stack. If the operator has less than or equal precedence than the op stack's current top operator, then we're going to pop op stack and keep popping op stack until we encounter an operator that for which the new operator has greater precedence, or we pop until the stack becomes empty. Once one of those situations get reached, we push the operator onto the op stack. If the token is open parentheses, push the token on the op stack, but do not pop it until the corresponding closed parentheses is met. If the token is closed parentheses, then we're going to pop the op stack until the corresponding open parentheses is met. Then we're going to discard both tokens.